All right, well, hello everyone, and welcome back. In today's video, we're going to continue our discussion about arrays in C++. If you haven't already done so, make sure that you have viewed our previous video introducing arrays before continuing with this video. So here's our goals for today. First, we're going to start by briefly reviewing what we learned last time about one-dimensional arrays. We'll also complete what I call the array sandbox. One of the best ways to get really good at arrays is to practice writing lots of programs using different kinds of arrays. So we'll go through my sandbox and practice writing some short programs to get comfortable using for loops to manipulate arrays. Next, we'll learn about how to use arrays and functions together. And you'll see that it's actually pretty easy to write a function which uses an array. We just have to be careful of a few important rules. All right, so let's go ahead and begin with a little bit of review, and then we'll move on to the array sandbox and how to use arrays and functions. So you may remember from our last video that arrays basically allow us to allocate blocks of memory large enough to store sets of different kinds of data. For example, if I declared this array named myNumbers5, what this does is this creates a block of memory large enough to store 5 int-sized variables. And you'll want to make sure you remember the array numbering conventions. Remember, array numbering starts at 0. So the very first element in my array, we actually call it our 0th element, and this will be my numbers element 0. And then our element 1, 2, 3, and 4 will fill up our array. So notice here that basically you want to make sure you remember that the very first item in our array is actually element number 0. Then element 1, 2, 3, and so on will continue in the array. And our very last element in our array will actually be number n-1. So in this case, my numbers 5, the very last element will actually be my numbers element 4. And that is because since our numbering starts at 0, our very first element is numbered 0. Last one will be the total number minus 1. And because of this numbering convention, that's also why most commonly we want to start our for loops with our counting variable initialized to 0. Often we use for loops to manipulate arrays, so we want to make sure we don't forget about our element number 0 when processing our arrays with a for loop. In our previous video, we also reviewed how to process array contents. This is one of the most important things to remember about arrays. So please make sure you remember this. In order to manipulate the contents of an array, you need to use loops to manipulate the array element by element, or one element at a time. We cannot simply take a whole array and assign it the values of another array. We have to go one item at a time in that array. And in our previous video, we reviewed how we can use a for loop to complete all of these different tasks. For example, a for loop with a cout statement can be used to output each array item to our screen. Or we can use a for loop and if statements in order to compare two arrays and verify whether the arrays are the same. Remember, you have to check each item one at a time. Same thing goes for setting arrays equal to each other. We have to literally go element by element and set element I on one array equal to element I in the other array. Also, for summing and averaging, we need to use a for loop with a summing variable and a counting variable. We calculate how many things are in our array, and we calculate the cumulative sum. And finally, for finding minimum and maximum, we can use a similar approach. We use a for loop to read our array one value at a time, and then use if statements to compare each element in that array to the minimum or maximum. Often it's also convenient to use the very first item in the array as our initial minimum and maximum value. That way you can compare all the other values in your array to that very first value. Finally, in our last video, we learned about things to watch out for when working with arrays. These are some very good practices that you want to make sure you follow. First, most of the time you should use constants to specify the size of your array. For example, when you're declaring an array, you could use a global constant named size in order to specify how big that array is. And that makes it a lot easier if you ever need to change the size of your array later on. Also, remember to properly initialize your array. Remember, arrays have to be initialized by us. Arrays are not initialized automatically. So you want to make sure you go through and use a for loop to assign some initial values to your array. Next, be careful of out of range errors. Remember to start your for loops at 0 and end your for loops at element n-1. That way, you'll make sure that you don't forget to read any of your array values. Also, be careful of out of range errors where you accidentally go beyond the bounds of your array. So if your array has 5 items, you want to make sure you process item 0 through 4. If you try to process index 5, then you will actually be going outside the range of your array. And also be careful of those off by 1 errors. Make sure your for loop is correctly processing all the elements in your array. You don't want to accidentally be off by 1. All right, so real quick, before we continue on to our array sandbox, let's try a quick practice question. So suppose I have an array called test scores. So this is a double type array. Double type array named test scores. And notice the test scores array contains num students elements. Here, num students is set to 30. So let's assume that our test scores array contains 30 elements. So here we need to write the C++ code which will search through our array and set a variable named perfect score to be true if test scores contains the value 100. So let's assume that we've already declared this bool type variable to be bool perfect score. And let's set it to false initially. Now we want to go ahead and use through that array. So in this case, we want to go through and start. So we first say, okay, starting with element I equals 0, as long as I is less than, and we increment our indexing variable I each time. Then we can put some curly braces, and we can put our code inside that for loop. So this for loop is going to search through each element, starting with 0 through students minus 1. Let's see what code we need to put inside our for loop. Inside our for loop, we need to use an if statement to check whether each element contains the value 100. So we need to check if the current element contains the value 100. What we'll do is we'll write if test scores element I double equals 100. Remember, we need to use double equal here because we are comparing test scores element I with the number 100. If test scores element I contains a value 100, then we set perfect score to be true. If test scores does not contain the value 100 exactly, then this if statement will not trigger. So that's all we need to do. We're checking each element inside our test scores array one at a time, and if the ith element contains the number 100, then we can go ahead and set perfect score to be 100. We could even add a cout statement to let us know that element I contained the perfect score. So notice these for loops are actually fairly simple to write once you get the hang of it. So make sure that you practice as much as you need to get really comfortable writing these for loops. This is actually so important that I'd like to spend a little bit of extra time working on what I call my array sandbox. This array sandbox contains some short practice programs to help you get comfortable with arrays. So let's go ahead and open up this array sandbox in Sea Lion and give it a try. So if you open up our sample code, you will see that the array sandbox looks something like this. The array sandbox starts with some sample code. So here I'm just showing some basic array operations. For example, here I'm declaring this array named myNumbers. It's an int type array, and I'm using this global constant array size to specify how big my numbers should be. Notice all the way up outside my main function, I have declared a global constant array size and assigned it the value 10. Notice I have used the const modifier here while declaring array size. That allows me to declare array size as what we call a global constant. Anything that comes after this declaration will be able to use the array size here, and everything will know that array size is currently containing 10. So down here you can see that Sea Lion is already recognizing that I have set my constant array size to be the value 10. In this next line, I went ahead and initialized my array myNumbers to have each value containing the number 0. I then use a second for loop in order to output the numbers to the screen. If I run this array sandbox program, you can see the result of that initial code. So you can see if I output these results to the screen, myNumbers contains array size numbers. We see myNumbers contains 10 numbers. Array size is 10. And then first, we initialized all our numbers to 0. And so we did that using our for loop, and you see each element of myNumbers currently holds the value 0. In the next part of the sample code, we manipulate the myNumbers array a little bit. Here we assign the values 0 through 9 to myNumbers. So notice what we do here. We take our counting variable I, and we are simply assigning the ith element of myNumbers to contain the value I. Element 0 would be assigned the value 0. Then I is incremented during our for loop so that myNumbers element 1 would receive the value 1. And so after that for loop runs, we can use a second for loop to output the results. And if we look at our array sandbox, we see that's indeed what happens. Element 0 receives the value 0. And as we increment our counting variable, you can see that the next element is assigned the next value of I. And just for fun, notice that we can actually output individual values from our array directly by using our square brackets. So, for example, we could write that the first item in myNumbers, that's index number 0, we just take the name of the array, myNumbers, and we put index 0 in square brackets, and notice we can successfully output the first item in myNumbers, index 0, is 0. And similarly, we can see that the last item, notice here I wrote it in terms of array size, because our last item will be array size minus 1. The last item in our myNumbers array will be myNumbers, and then inside the square brackets, we put array size minus 1. And in this case, we see that yes, indeed, since we had initialized myNumbers to hold 0 through 9, the last item in our array contains the number 9. And so we see that yes, indeed, last element holds the number 9. So that was just some sample code to get you started. In the next part of the array sandbox, we actually want to give you the chance to start writing some code. And so you'll see that there's some practice questions with blank sections. So the idea here is you can write in some code and try to answer these practice questions. In the next part of this video, let's go ahead and try these practice questions one by one. So in our first practice question, we want to write another loop which will modify that array named myNumbers. So remember, we currently have the array myNumbers, which contains array size elements. So what we want to do in this first practice question is we want to write a loop which will set the values of odd numbered elements to be 1 and then assign the even-numbered elements the value 0. So what we want to see, if we do this, if we update our myNumbers array, remember we have element 0, 1, 2, 3, 4, 5, 6, 7. Oops. So we've got currently 10 items in myNumbers. We want to write some code which will update the odd numbered elements. So that's element 1, 3, 5, 7, 9. We want those to hold the value 1. And we want even numbered elements to hold the value 0. So basically, we need to use the counting variable I to help us check whether our element is even or odd. We have a hint here that we can use modulo 2 to check for even odd. So for example, we can use an if statement, like if our counting variable I modulo 2 double equals 0, that means we're a multiple of 2, then the element is even. And otherwise, element is odd. So what we can do here is we can actually just write a for loop that will allow us to update myNumbers element I to be either 0 or 1, depending on the element. So if our element is even, then we need myNumbers element I to be 0. If our element is odd, then myNumbers element I must be assigned the value 1. Then after we have completed that task, we're also asked to output the values of our array to the screen, each one separated by a space. Let's go ahead and try coding up this example. So here we are in CLion, and notice I'm still inside the main function that I had written for this array sandbox. So I'm going to go ahead and just start writing some code directly in this practice program. So in this case, I need to go ahead and make my for loop. And I'm going to go ahead and use a new counting variable I. So I'm going to have int I equals 0 here. And I need to keep going as long as I is less than array size. And I want to increment I by 1 with each run of my for loop. So I'm checking each element 0 through 9. And first I want to determine whether my index is even or odd. Remember, if I modulo 2 is a 0, then the index I is even. So in this case, let's go ahead and use an if statement here. If I modulo 2 double equals 0, remember, double equal for comparison, then what do we need to do? Then we need to set myNumbers element I to contain the value 0 because our index is even numbered. Then here you could either use an if statement or an else statement. I'm just going to go ahead and use an else because I know my elements are either going to be even or odd. So if I'm not even, I must be odd. So here I'm going to set the odd elements to have value 1. And then finally, the last thing I need to do is I need to output the values of my array to the screen. I could write a separate for loop for this, or I can actually just do it inside my current for loop. I just need to make sure my else statement has ended. And then I can go ahead and use a cout statement to output my numbers element I. And then I want it separated by a space, so I will also output a space. So I just put a space just like that. Let's also do just a little bit of formatting with Control-Alt-L, make sure everything is nice. And let's go ahead and run this program. If we've answered correctly, our code will appear in this question 1, and we can see whether we completed it correctly. And what do you know? There we have it. So our 0th element was assigned number 0, first element assigned number 1, and so on. So we've correctly completed question 1. So in our question 2 of our array sandbox, we want to modify the myNumbers array again. Here we're being asked to assign the array the values 9876, 54321. So we want index 0 to be set to the value 9, and then each subsequent index is set to one number less. And then we want to output the values of our array to the screen, with each one separated by a space. So to approach this problem, it's convenient to, once again, use the counting variable I. And use the counting variable I to help us assign value. Because we know that, for example, if I have myNumbers, I have my myNumbers array, we want element 0 to hold the value 9. So that one's easy. We can just say myNumbers element 0. Well, we want that to be 9. myNumbers element 1 should be 8. What about myNumbers element I? Notice for any element in this array, the value of the ith element should be equal to 9 minus I. Because we want to start with element 0 equal 9. And then as our value increases, as the element number increases, we want to subtract by 1 more each time. So element 1 will contain 9 minus 1, or 8. Element 2 contains 9 minus 2, or 7. Finally, element 9 at the very end, that will contain 9 minus 9, or 0. So this is definitely one of those situations where it's helpful to use that counting variable I in our for loop to also help us determine the value to put in our array. So here we are in our practice question 2. Once again, we want to modify our myNumbers array using the for loop. I'm going to go ahead and start my for loop again. I've got my counting variable I. I want to keep counting as long as I am less than array size, and increase I by 1 each time. As we discussed, all we need to do here is assign the ith element the value 9 minus I. Or if we want to be more generic, we can actually say array size minus 1 minus I. And then finally, once we have assigned the value, we want to output the result to the screen. So we can use a cout statement again, and we can just output my numbers element I and have a space in between each value. If we go ahead and run this, look what we get. Indeed, we get 9876543210. All right, so in our next example, we want to modify the my numbers array once again. But this time, we want to write some code and a loop which will first sum all the values in the array. And then I want to output the sum to the screen. So here we need to use a summing variable. So let's sort of see how this works. We could declare a summing variable, for example, int or double. Let's do double just to be safe in case we ever had a decimal. You want to make sure you always initialize your summing variable to 0 before you start adding stuff to it. Once you have your summing variable, then you can start your for loop. Inside your for loop, you want to add each element I in the array to the summing variable sum. So in this case, we could write sum equals sum plus my numbers element I. Notice inside our for loop, this would allow us to add the ith element to the cumulative sum. And then once we have summed all the values, all I values in our array, then we can output the sum to the screen. So remember, in order to actually perform these calculations, we have to go element by element. And so in this case, we add my numbers element I to the cumulative sum each time the loop runs. Let's code this up in C-line. I'm going to declare a summing variable named sum. And notice I'm initializing it to 0 right away, because I know that I'm going to start adding things to that summing variable. So I want to make sure it's initialized. Also here, I went ahead and declared the summing variable to be a double type. I know my array currently holds ints, but just in case we ever changed our mind and decided to have doubles in there and change the array type, I don't want to have any truncation errors. So we'll just leave that summing variable as a double. And then what do? We need to set up our for loop again. In this case, we're going to go ahead and read through our entire array, starting with element 0, ending with element I minus 1, which would be array size minus 1. And then we increase by 1 each time. Remember, we're trying to calculate the sum of all the elements in the array. So inside our for loop, we need to add each element I to the cumulative sum. So here we just write sum equals sum plus my numbers element I. Just for fun, so we can see what's happening, I'll add in a little bit of extra code here. So notice if you ever want to see what's happening, You can use a cout statement or run the debugger to see what's going on. So here, I know that initially my sum is currently some value, and then I can say adding, I want to add my numbers element I, and then we can say the sum is now just going to be sum in this case. So again, this is just extra code to help you see what's happening as each iteration of the loop runs. So here I'm just adding a little bit more code so we can track what's happening. So if we go ahead and run this loop, you'll see essentially what's happening is we'll be able to track our sum as each element is being added. So notice what happened for question 3. Initially, my sum is 0. My array contains 98765432110, because that's what we had initialized our array to be in the previous question. So our sum is initially 0. We add element 0 to the sum. Our sum is now 9. Then our loop runs the next time. Currently, our sum is 9 from the previous run. We add our second element, which is 8, to the sum. The sum is now 17. In our third run, our sum is 17. We add 7. Our sum is now 24. And notice we keep repeating and repeating all the way until we get to the very end. With our last run of our loop, our sum is currently 45. Our last element contains 0. So our final value, once we have completed the summing, gives us 45. So I'll go ahead and delete that code from our loop now that we've kind of seen what happens. The only thing that we actually have to have in this for loop for this question is calculating the cumulative sum. And then finally, we output the sum after our loop has finished. And notice that I also declared sum outside the loop so that sum is still available for my statements that come after. So it's a good idea to always declare summing variables outside of that for loop so that you can access them after your loop has ended. And see here, now we have determined the sum of our elements from the previous question is 45. So there you have it. That concludes question 3. All right, here's our next question. We want to once again modify our my numbers array, but look what we want to do now. We want to sum only the first 7 values. How would we make our program only sum the first 7 items in our array? There's a couple approaches you could use for this type of program. One approach is you could modify the Boolean statement and the for loop statement to stop after I is less than or equal to 7. So basically, we want to sum the first 7 values. First 7 values is my numbers element 0 to my numbers element 6. So once I becomes greater than 6, then we could stop our loop, and that would stop us from summing. You could also put an if statement and a break statement in the loop. So you could have something like if our counting variable I is greater than 6, then we put a break statement inside that will stop our for loop. So there's multiple possible ways of writing this program. All right, so here we have our question 4. For this program, we can actually reuse our code in the previous question. The only thing we want to do here is we don't want to redeclare sum. So we want to just simply update our summing value to be 0 again. Remember, we can't redeclare a variable multiple times within the same function. So I'm just going to go ahead and update sum to be 0 again. And then notice here, one approach I can do to stop my summing is I could say, okay, keep summing until I reach 7. So in this case, I could say the sum of the first 7 elements, that will be elements 0 through 6. I can do it like that. And let's see what we get. So we have the sum of our first 7 elements is 42. So we have element 0, 1, 2, 3, 4, 5, 6. So notice we're basically summing 9, 8, 7, 6, 5, 4, 3. That gives us 42. And then 2, 1, and 0 have been skipped because our loop only counted the first 7 values. The other possible way that we could have done this loop is we could have done an if statement where if I is greater than or equal to 7, then we break. And that would also allow us to stop before we have read element number 7. And you'd see we get the same result. So that concludes our practice question 4. All right, so in question 5, we want to declare a second array named my other numbers. My other numbers should be of type int and size array size. And we want to use a loop to initialize my other numbers so that its values are equal to my numbers except they are doubled. So essentially what we're saying here is we want my other numbers, element I, to be equal to 2 times my numbers, element I. And then we want to output the values of my other numbers to the screen. Let's go ahead and code this up in CLAN. All right, here we go with question 5. So we first need to declare another array called my other numbers. So I can simply say int my other numbers, which is also array size, elements. Just go like that. This is declaring my other numbers. And then now I just need to initialize my other numbers. Remember, I cannot go like this. Notice this will not work. I'm getting an error here. And CLine's like, hey, what are you trying to do? You have an invalid operand. You cannot just multiply my numbers by 2. This won't work. Remember, we need to use a for loop to manipulate our arrays element by element. So in this case, what do we get? Well, let's use a for loop. And we can start at from element I equals 0. I is less than array size, incrementing I each time. And in this case, all we want to do is set my other numbers, element I, to hold the same value as my numbers, element I, but I want to multiply my numbers element I by 2. And then finally, I want to output the values of my other numbers to the screen. So let's also add in a cout statement to output that ith value of my other numbers to the screen with a space in between. So if we have written this loop correctly, we should see that my other numbers contains the exact items as my numbers, except doubled. And if we run this code, notice that's exactly what we get for question 5. We see that my other numbers contains 18, 16, 14, all the way down to 0. And remember, my numbers just contained 98765432110. So we successfully doubled the values in the my numbers array and assigned them to my other numbers. Notice how just these short lines of code actually accomplish quite a bit. In the last question of our array sandbox, we're asked to declare another array called mySum. MySum should be int type and size array size. So essentially what we're trying to do is we want to declare an array called mySum. So we have our array mySum, where each element of mySum is going to be my numbers, element I, plus my other numbers, element I. So for example, in index 0, we know that my numbers, element I, will be 9 at index 0. My other numbers will be 18. So my sum at element 0 should contain the value 27. All right, so first we need to initialize that other array named mySum. So I'm just going to call it int mySum, and mySum should contain array size elements. And next, we just have to use a for loop. And notice what we do in here. We literally go through from element 0 to array size, and we say that mySum element I, mySum element I should contain my numbers element I plus, oops, type correctly, my numbers element I plus my other numbers element I. And then, just to make sure we're not crazy, let's output my sum element I to the screen so that we know that we did this correctly. And if we go ahead and run that, you see, indeed, we get the expected result. So hopefully by now, after practicing these sandbox examples, writing the for loops is becoming a little bit easier. Please take the time you need to go back and make sure you're really comfortable writing these for loops and manipulating items in one-dimensional arrays. This is a really important skill that comes up a lot, both in this class and in other programming classes that you might take. And if you'd like additional practice, try modifying some of these examples further. Let's now continue on to some new topics for today. First, we'll briefly cover range-based for loops. Then we'll talk about some more useful hints for keeping array size handy and also use of parallel arrays. First, let's cover range-based for loops. I'd like you to know that range-based for loops exist, but for the purpose of this class, I will not cover range-based for loops on any exam. Range-based for loops are a special version of the for loop, and the purpose of a range-based for loop is to try to help simplify special cases of for loops. The range-based for loop automatically knows how many elements you have in your array, so you do not need to use a counting variable, and you do not have to worry about stepping outside the bounds. Please note that these range-based for loops are really only useful primarily for one-dimensional arrays. They can be a little bit tedious to use with multi-dimensional arrays. But I do want you to know what the syntax looks like so that if you see a range-based for loop, then you'll understand what it is. Here's an example of a range-based for loop being used. If I have this array named numbers, so here I've declared and initialized the array numbers to contain 10, 20, 30, 40, 50, notice that if I want to output the values of numbers to the screen, I can use this special syntax. For int val in numbers, I output val. So essentially what this is doing is it's going through each element of numbers and outputting that value to the screen. If you just need to do something quick, like outputting the numbers in a one-dimensional array, the range-based syntax can be useful. But I personally find that this syntax is not that helpful when you can just use a for loop to do the same thing. And so I prefer to just use regular for loops. And for the purpose of this class, I just expect that you know that range-based for loops exist. For most of our assignments and most of what we're doing in this class, range-based for loops generally won't work for what we're doing. So we typically just use regular for loops, and that usually works just fine for what we need to do. All right, so the next topic for today is a recommendation on working with 1D arrays, or any array, really. It's always a good idea to keep the size of your array handy. And you'll remember that we often recommend using a global constant to help specify the size of your overall array. Sometimes we don't know how much data is going to be put in our array. So in some programs, like in some of our assignments, what we do is we declare our array to be very large. As a temporary workaround, it works all right for some of our assignments. We'll learn about more efficient ways later on in the course. For now, if you wanted to use an array and you weren't sure how much data was actually going to be stored in that array, what you can do is you can declare your array to be plenty big, make it 100 or 1,000 items big, and then you can declare and define an extra variable to track how much that array is filled. That way, when you're processing an array and maybe it's only partway full, you can keep track of how much that array is filled, and you can use those variables in your functions and loops. And this is a common situation I give in some of our assignments where if we don't know how much our array will be filled, it's very useful to have another variable that keeps track of how much stuff we actually put inside our array. So in this example, you can see that we have declared the maximum size of our array, or the maximum number of values in user message, to be 280. So we've declared a user message array, and we've set the maximum size of that array to be 280 characters. But if our user is inputting data into this array, there's no guarantee that the user is always going to give us 280 characters. What if they only have 2 characters? And so notice what I did here is I declared an extra variable to keep track of how much data has been entered into that array. So in this case, you can see what the user is doing. Here, the user is supposed to enter their message 1 character at a time and then enter 0 to stop. So once the user enters 0 at the end of their message, then we assign user message length the value count. So basically here we're saying, okay, our user has entered however many letters, that is the length. And then we have a break statement to exit. And then finally, you can see that later on, if we want to use for loops to output how much stuff is in my array, instead of using max length as my size of the array, I can use user message length in for loops to help keep track. And this will ensure that I only output as part of the array that was filled. So this is a really useful strategy if you ever have to write a program where you're not sure how much of your array is going to get filled. You can use that variable to keep track, and we'll know exactly how many items the user has entered, and we can use that value to help us each time we need to manipulate the data in that array. Let's go ahead and run this in CLion briefly. So here's our example code once again. And if we go ahead and run this example, look what we get. So we're asked to enter our message 1 character at a time and enter the next letter. So I could say like HELLO for hello. And then I'm just going to go ahead and say 0 to stop entering letters. You'll notice the output here is a little distorted. That's just from the CLion console view. The actual program is outputting data just fine. Notice here, I only entered 5 letters. And because I had that user message length variable to track how much I had entered, I was able to save how many items I had entered and recognize that later on when I want to output my data, I only output the number of values that I had entered. Notice if I had not used user message length here and I had just used my variable max length, then if I run this program, then look what would happen. I would try to output all the things in that array, including the uninitialized data. So I'm seeing like all this extra garbage, that's uninitialized variables inside my array. CLion doesn't know what to do with them, so some of them got translated into funny Unicode symbols. So if we want to know exactly how many things we've entered, it's a good idea to use a tracking variable, like user message length. That way, if our array is only partially filled, then notice if we use user message length, then we will only output the parts of the array that we have filled. This is an extremely useful strategy. Please keep this in mind if you need to code up any kind of assignment or practice program where you only want to use portions of an array. All right, our next topic for today is parallel arrays. Parallel arrays are arrays that contain related data. A good example of this is if you have like one array that has x coordinates and another array that has y coordinates. For example, like x and y coordinates in a Cartesian plane. You could design the arrays such that the x value and y value at index I are related. So this is a very common situation where the ith element, so it would be x val element I and y val element I, those two are part of a set. So by keeping track of which item is at each subscript or each index, you can store sets of related data. And notice this could also be useful if you have arrays of different types. So maybe you have a string array that is like the name of the data point. And so you could have like test1 be related to xval element I and yval element I, and so on. So parallel arrays are very useful when you need to store sets of related data in multiple arrays. Here's a short example. So suppose you wanted to store employee hours and pay rates in sets of parallel arrays. So you could have one array holding the employee's hours and another array holding the pay rate. And basically each employee number would share the same index I between their hours and pay rate. So we designed this program such that we have num employees as the size of our array. So each index I holds the data for one employee. And notice what we do is we can use a for loop to enter the hours and pay rate for each employee, and then calculate gross pay by multiplying hours and pay at the same index. So here's our example program with the parallel arrays. Notice the types of the arrays are different. We have an int array for hours and a double array for pay rate, but that's okay. These two arrays are separate, so we can just have int type data in hours and double type data in pay rate. Then we have a total of 5 employees, so both hours and pay rate are set to have a size of num employees. Then we're prompted to enter the number of hours worked by the employees. And notice what we do here is we literally go through and we use a for loop to step through each element in both hours and pay rate. We ask our user to give employee number one's hours and pay rate, and that data will be stored at one index. And then basically all the employees' data will be stored at the same index in both of the arrays, so that later, if we want to calculate the gross pay, notice that we can actually just calculate for each of our employees, their gross pay will be the employee's index in the hours array times the pay rate at that employee's index. So if we go ahead and run this, you'll see we're prompted for hours worked by each employee. So maybe employee 1 worked 40 hours, $20 an hour. Employee 2 maybe worked 20 hours for, $15 an hour. Maybe employee 3 worked 50 hours for $30 an hour, and so on. So you can just enter everybody's hours. And notice that the program will basically multiply the same index at both hours and pay to get the pay rate. So employee 1 worked 40 hours times $20 an hour to get $800 of pay. So parallel arrays can be very handy if you need to write a program where you have related sets of data. You can use the index I within each different array to help relate different values between data sets. Let's now move on to our last topic for today, which is arrays and functions. If you have any other questions on what we've covered so far, remember you're welcome to reach out. So let's talk a bit about how to use arrays with functions. It is perfectly legal to use arrays with functions in C++, and it's actually a very common thing that we need to do. We often need arrays to be arguments when we write functions. So when we use an array as an argument in a function, sometimes it's called an array parameter. But here you want to be careful because there are some important things to watch out for when using arrays and functions. There are some differences. So you can't just directly plug in an array like you would with a regular variable. Let's cover the important differences when working with arrays and functions. First thing to notice about arrays and functions is that arrays are a little bit different than the other variables we've worked with. Remember, the name of an array only stores one thing. The name of an array only stores the memory address of element 0 in that array. That's it. All the array stores in that name is a memory address or a location in the memory. So that is all we get when we plug an array into a function. Notice that the memory address will not tell the function how big the array is. It's not going to directly tell the function all the data in that array. So generally, when working with arrays and functions, you need to either pass another variable to your function to tell the function how big your array is, or you need to declare a global constant for the size of the array. And that way, if the functions have access to that global constant, which again, if it's a global constant, they will, that way functions will know how many items are in the array, and you can write for loops. So very important to remember, the name of an array only stores the memory address of its 0th element. So we have to tell our functions how many items are in our arrays. Because of this difference, there's some important rules that you're going to want to be careful about. Here's some important rules to follow when using arrays in functions. First, if you are calling a function which takes an array as the argument, you just use the array's name. So for example, if I have the tests array and it contains 5 items, I do not put tests and 5 in square brackets in the function when I call it. All I do is I give output to screen the name of the array. So when calling a function that takes an array as the argument, I just give it the name of that array. Then when declaring and defining a function that takes an array as an argument, notice that we have to put empty braces next to the array's name. This tells the function that tests will be an array argument. It's similar to the ampersand in call by reference. So if you are declaring a function that uses arrays as an argument, make sure you put those square brackets next to the array name in both the declaration and the definition. Remember, in the function call, you do not need square brackets. You just put the name of the array. Next rule. As we mentioned before, functions will not automatically know the size of your array. So whenever you're working with arrays in your function, you have to tell your function how many things are in your array somehow. One way to do this is to use array size, or pass in a second parameter to specify the array size. So in this example, we declared another int value named size so that we can plug in the size of our array to that function. But the other way to do this, if you don't want to have another argument, is you could use a global constant. So at the beginning of your program, you could have some constant like size, and you set it equal to something. And then that way, if your function has access to this constant, then we'll know how many things are in your array. Your next rule, if you do pass a variable to store size in your function, remember that you do need to put that variable in the declaration and definition as well. Next couple rules. Arrays are passed by reference. So when you use an array in a function, changes made to that array will be reflected in the actual array in the memory. So arrays automatically use pass by reference. Remember, the name of an array is actually a memory address, so it's just like pass by reference, where you're telling the function a location in memory where it should manipulate data. So please remember, arrays automatically use pass by reference. But that brings us to our next rule, that you need to be careful. Since arrays are automatically passed by reference, you want to make sure that you don't accidentally change something that you weren't intending to. So be very careful. Make sure that you don't accidentally change something, because those changes will be reflected back in the main function. Another very important rule. Functions can return values that are int type, double type, char type, whatever type, but functions cannot return arrays. So we can't make a function that's like int5 type. So you cannot make a function that returns an array as its return type. So that's okay, because remember, we can still use pass by reference. And there are workarounds that we'll learn about later, such as pointers and dynamic arrays. But for now, please remember that functions cannot return arrays. So we'll take a look more at workarounds later in the class. Our last rule here, if you want to be really careful and make sure that your function cannot possibly change stuff in your array, you can also use what's called the const modifier in the declaration and definition. Const works like an ampersand, I like to call it, because it prevents the contents of that variable from being modified. Program won't even compile. program won't compile if something marked const is being changed. We'll take a closer look at the const modifier a bit later when we cover objects and classes. So don't worry too much about it now for arrays and functions, but we will revisit it later on. The important thing to note here is if you do put the const modifier in your function declaration, make sure that you also have it in your definition next to the arrays that you want to protect. Finally, to get some practice, let's go ahead and try modifying this parallel arrays program so that rather than having code in the main function, let's replace that code in the main function with two other functions. Let's replace our code in the main function with a function called getHours and payRate and a second function called displayGrossPay. So here I have my parallel array program. But remember, I want to try replacing these tasks inside my main function with functions. So I'm going to declare two functions which use the arrays. So my first function, we're going to go ahead and call it getHours and payRate. And notice in this case, it's actually going to be a void type function because we can't return an array, but we can modify an array using pass by reference. All right, so the getHours and payRate function, that's going to need to accept two arrays as arguments. It's going to need to accept one array named hours and another array named payRate. And notice here, since I had my hours array as int type, I'm going to just go ahead and leave my argument array for hours as int type as well, just so we match what we had in main. With each declaration, we need to have our precondition and postcondition. Okay, so for getHours and payRate, here's an example of what the precondition and postcondition could look like. Our precondition is that hours and payRate are two arrays of size num employees. And again, these would be initialized in main. So there, let's just call it declared in main. And then our global constant num employees must be initialized to some valid value, so greater than or equal to 0. And then our post condition is that we're going to prompt the user for the data to input into hours and payRate. And the other function we need to write is called displayGrossPay. And this function will also take hours and payRate as its arguments. So let's make sure we correctly remember we need to put square brackets next to each array name. I had forgotten that in payRate. And here in our precondition, we need hours, payRate, and num employees to all be initialized to valid values. And then in our post condition, what we will do is we will output the employee gross pay to the screen for all num employees. Oh, and let's not forget our semicolon. So with that, you can see our declarations are complete. Here I did not need to pass an extra variable containing the size of the array, because what I'm going to do is I'm going to instead declare a global variable. Let's declare that global variable. So instead of having it inside main, I'm going to move num_employees to be the global constant. This way, if I have this constant declared globally, all of my functions can access num_employees. So I moved my constant to be a global constant so everybody can access it. However, notice this is a constant because I used the const modifier here and I gave the name all capital letters. All right, so I've declared the functions. Now let's go to the end of our main function and let's define the functions. So I need to go ahead and define get hours and pay rate. I'm going to go ahead and just copy my header because I'm going to contain the same things here. And my function get hours and pay rate is going to need to do the tasks that we had already written in main. So basically, I want to take this code prompting the user to enter the data, and that code will actually be put inside get hours and pay rate. Then inside my main function, I will simply call get hours and pay rate using the function call. So I'll use get hours and pay rate, and I need to first give it my number of hours and then pay rate. And notice I just give it the name of the arrays to plug in as my argument. Notice that get hours and pay rate has access to num_employees because that is a global constant. Next, we need to write our function definition for display gross pay. So for display gross pay, let's go ahead and write that definition. And we've already written the code in main, so I'm just going to take the code I want my function to run. So here I am just outputting the gross pay for the employee at each index. And so if I want to actually calculate the gross pay, then I need to call display gross pay back in my main function. And so here, remember, I just go ahead and plug in. In this case, I'll plug in hours, pay rate as my two inputs. That will plug in hours to my hours parameter, pay rate to my pay rate parameter, and I will be able to complete my tasks. Let's go ahead and do Control-Alt-L to format this code. And let's try running this to see if our functions are working correctly. And you can see I'm being prompted to enter the data. So I'm just going to go ahead and enter some basic numbers here just so we can check. And we see that using arrays and functions, we were able to complete the same tasks. And we were able to make our code a lot more organized and easy to update later. The only thing we needed to have in our main function was the declaration for those arrays, and then the calls to the functions that we wanted to use. So I highly recommend you go back and try practicing this yourself. You'll see that writing functions with arrays is actually pretty straightforward once you follow the rules and get the hang of the syntax. All right, let's go ahead and wrap up here for today. So after viewing today's video, you should now be more comfortable using one-dimensional arrays in our programs. Please make sure you practice the array sandbox and additional examples on your own as needed to get really comfortable with for loops. Also, try going back through our example to write functions which use arrays. It's actually a pretty straightforward process, and we'll use it a lot over the course of this class. Feel free to reach out if you have any other questions on this material. In our next video, we're going to learn more about multidimensional arrays and also how to more efficiently search and sort inside our arrays. Thanks everyone for joining the fun, and we'll see you in the next video.